Hey y'all, let's see how long it takes people to show up here. See if we get enough people here. Okay, everyone. We got 9 people here. That should be good. How did it go? How did y'all feel about that?
Yeah.
It was okay.
Okay. For sure.
It
Yeah.
I'll take a 10
Wasn't too
minutes break
bad,
if
yeah.
possible, before the next.
Yeah,
It's what I expected.
yeah. Okay, so as long, I mean, when you took it, there should have been no surprises, except for maybe that word problem that had to do with the baking. But we did do that in class, so I threw it in there. Okay, so I hate to take a test and then do more material, but that's just the way the summer goes. So we're gonna just see how far we can get today. What time do we end? Is it
140.
40, right? Yeah. Okay, so let's see how far we can get with this in about 50 minutes. So we're going to be talking about a couple of things. If we look at our schedule, we want to talk about percents and proportions, and then applications of percents and mixtures. I doubt we're going to cover all of this. Let's see how far we get. I want to get through at least percent and proportion. So when it comes to percent and proportion, percent is something that all of you should be familiar with, because we use the idea, or you've heard the word percent used many times in your life. And so all we want to do is make sure we understand what a percent means, how to get a percentage. And so the first the first definition here in the packet talks about a fraction, which again, you all know what a fraction is. Another word for a fraction is a ratio. And all it is a number that can be written with some number over some other number, right? 3/4 or 3/4 or 7/10. So that's a fraction or a ratio. Another way you can think about a fraction is being the numerator, which is the top, okay? That's the top of the fraction, is the part of something that we have. And the denominator, which is the b on the bottom, is the whole. So if you look at this picture, we have an entire, let's say, pizza, right? And if we take this pizza and cut it into 2 equal pieces, and we take just one of them, the red shaded area, then we have taken part of the whole, right? We've taken one part out of the whole part, which has been cut into 2 pieces. So 1 divided by 2 as a fraction is written 1/2, but if you get on your calculator and you do 1 divided by 2, you get 0.50. This is the decimal, right? So that's the decimal. This is the fraction form. And then every single fraction can be written as a percentage. And to convert it to a percentage, there's a rule. To turn to a percentage, you take the decimal, and all you do is move the decimal point 2 spaces to the right. And then you add a percent symbol. So this, when you have 0.5, you imagine that there's an infinite number of zeros behind this. All we're going to do is move the decimal point 2 places, place it right there, write the word or the number 50, and then put a percentage symbol next to it. And that is what we all have heard of as percentages. So I know most of you are familiar with the idea of moving the decimal 2 places to the right. So again, 50% means 50 divided by 100, or 50 out of 100, which would mean half. So this is, if you start with a decimal, start with a percentage, and you want to get it to the fraction, what you do is you take that number, divide it by 100, and then reduce the fraction. So I'll give you an example. Let's see, I'm not going to do that example. Let's do this one right here. So there's a picture. We want to write that, express the shaded region of that as a ratio, a decimal, and a percent. So when we look at this, we want to know how many parts are we taking out of the whole. So there's 1, 2, there's 3, there's 4 parts, right? There are 4 pieces that we've cut it into. So the whole thing has been cut into 4 pieces. I put a 4 on the bottom, and we're only going to be taking 3 of them. So we're taking 3 out of the 4. And that's our fraction, as long as it's reduced, right? 3 out of 4. Then to go to a decimal, how do we do a decimal from a fraction? What are we going to do? Anyone? Calculator, okay? If you don't know what that is, some people will know 3/4 is 0.75, but I'm just going to go 3 divided by 4, my calculator, and I get 0.75. So 0.75 is the decimal. Okay, so there's my decimal, there's my ratio. And now as a percentage, I'm going to take this and move it over 2 places, right? 75 and do percent. All right, so let's do this. Let's play a little game here. There are 12 people right now in this Zoom session, okay? So I'm going to do a poll here. If you can't do the poll, that's okay. I'm going to ask you a question. So it's a yes or no question. And the question is, do you have any siblings, brothers or sisters? Okay, yes or no? Still waiting on 2 people. Some people may not be able to, depending on what kind of device they're on. Do you have siblings, yes or no? Okay. All right. So I'll give you the results, okay? Of the 11 people that answered, 11 students here, 8 have siblings. Okay. So now the question. What percent of students in this class have siblings? So if someone want to help me figure this out?
73%.
Okay, so how are you doing that?
You divide 11 by 8.
You said that the wrong way.
8 by 11.
So let's write it as a as a ratio first, right? You have 8 of 11, right? 8 of 11, 8 out of 11 of you have siblings, right? To write that as a fraction, I'm going to put 8 divided by 11. And then I'm going to get on my calculator, 8 divided by 11. And that on my calculator gives me 0.727272. It keeps going on my calculator forever. So I'm going to now convert this to a percent by moving the decimal 2 places. And so I get 72.7272. It keeps going, right? Percent. So when you're taking a test, I will tell you how many decimals to round it to. So I'm gonna ask us right now to round to 2 decimals. And that means we're going to look at the second decimal place, just to the right of the decimal place, 2 spaces. We're going to look at, that's the number we want to round. We want to round the 2. It's either going to stay at 2 or round up to a 3. So what we do is we look at the number next to it, 7. If the number next to it is 5 or greater, we round up, which 7 is 5 or greater. So that means I'm going to take the blue number and round it up to a 3. Understand? Any questions? Okay, let's do another one. Because it looks like we have a couple more students here. So let's see. I'm going to ask you a new question. So how about this? In the past, I've asked like how many people own iPhones, but then never, like most of you do. So let's do this. How many of you work? So yes, I work, or no, I don't. Okay, so here are the results. Everyone's voted. Thank you. I'm going to do this. I'm going to just squeeze this in here somewhere. Okay, so actually, that's kind of, it's the same results that we got for siblings. 8 out of 11 of you work. So let me ask this, if 8 of 11 of you work, so what percent doesn't work? So you have to be careful here because I'm asking how many of you don't work. 8 out of 11 you do, of you do. I'm asking what percent of you don't. So someone want to tell me the fraction that I'm going to use here? 3 over 11, right? So you have to figure out if 8 of 11 of you work, you have to figure out how many don't, which means there's 3 of you that don't, right? 11 minus 8. So 3 out of 11 don't work. And so we go and we do the same thing. And you get 0.272727. Move the decimal point 2 places to the right, 27.2727. And now let's do this one. Let's round this 2 decimal places again. So if we go to the second decimal place, it's a 7. We look to the right of it, it's a 2. And if it's less than 5, then we leave the blue number alone. So since it's less than 5, my final answer, oh, I forgot the percent. My final answer would be 27.27%. Okay, so that's percentages. And now we're going to move on to proportions. So proportions are different than percentages. All right, so we need to be able to make the distinction between the two. A proportion is an equation where you have 2 ratios set equal to one another. That is A over B equals C over D. So I'll give you an example of a proportion, just so you can see it. If I take 1 divided by 2, okay, that's a ratio, 1 out of 2, is equal to 5 out of 10. That is a true statement. Do you all agree? 1 out of 2 is the same as 5 out of 10. And the way you can confirm that this is true is to say, all right, well, on the right side, the fraction 5 goes into 5 once, 5 goes into 10 twice. And so you get 1 over 2 equals 1 over 2, which is true. So for a proportion to be a proportion, it must be, the equation has to be true. Like if I wrote 1/2 equals 5 over 9, that is not, that's not a proportion, right? Because these are not equivalent fractions. So let's see if we can't see how you can use proportions to solve problems. I'm going to do this on a different page. All right, so this problem says, suppose after you graduate from college, you start a job earning $21,500 over a 6-month period. If your pay stays at this rate, how much will you earn in 1 year? Now, I know a lot of you can just think through this and be like, okay, well, if I earn $21,500 in 6 months, then in a year, I'm just going to double it, right? Because 12 months in a year. And that's great. But what we're trying to do right here with this problem is to understand how you can use proportions to solve more complicated problems. So let's first identify what it is we're trying to find. Okay, so what do we want? What are we being asked for? We want what? So look, read it and tell me what it's asking you to determine. Anyone?
We want to know how much we'll earn in a year.
How much you're going to earn, right? In 1 year. So what we want is to know how much you will earn, right? How much money you're going to bring in after a year. But the big key is that you want to know how much you earn, right? So we want the money earned. Okay? That's what we want. We want to know how much money we're going to earn. Now, what are we given? We're given in the problem a ratio, okay? And this is where things are important as far as being able to do harder problems. We're given a ratio. The ratio we're given is that we make $21,500 every 6 months. Now, that is a ratio, and there are 2 ways to write that ratio, okay? 2 ways I can write this. I can write $21,500 per 6 months, which means I put that over 6 months. Or you can write it the other way around. Every 6 months, you make $21,500. Okay, so it's very important. Anytime you're given a ratio, okay, you can always write that ratio 2 different ways. You can write 21,500 over 6, or you can write 6 over 21,500. Now, why is that important? Why is this important to solving problems? Well, because when you're trying to figure out how much you're going to make, you always want to, what we're going to do is create a proportion. A over B equals C over D. We're going to create this proportion, and we're going to use one of these 2. We have to determine which one we're going to use. And the key to figuring out which one to use is based upon what it is we're trying to find. So if we want to know how much money, right, how much money we're going to make, then the one we're going to choose is the one that has the money on top, which is this one, okay? So watch the way I write this. The money we're going to earn, okay? So I'm ready to start solving the problem here. The money we're going to earn over the time that we're going to be earning this money, 1 year, is equal to this proportion, 21,500 over 6 months. Okay, so again, we want to know how much money we're going to earn. We don't know yet. For working 1 year, that should be proportional to the money we were making, which was 21,500 over 6 months. Now, the way this is written is not correct yet. Can y'all see what there's a problem here with something? In both numerators, we're talking about money, right? In both denominators, we're talking about time. But what's wrong with the times?
They're measured in different ways.
Yeah, they're measured in different ways. One of them is months and the other one is years. So we need to make them both years, or we need to make them both months. And I think it's easier to convert a year into 12 months. Do y'all agree? So I'm gonna replace that 1 year with 12 months. Again, I want you to just ignore the fact that you could have given me this answer a long time ago, all right? By just doubling the answer. This is more about how do we do this for more complicated problems, which are going to come later. So now here's where we are. We have the money we're going to earn over 12 months equals the ratio we know is true, 21,500 for every 6 months. Now the money we're going to earn, let's give that a name. Let's call that X. And so now watch what I write. X over 12 equals 21,500 over 6. And what I've done is I've created a linear equation. Okay, this is something that we have studied already. Do y'all see that that's a linear equation? It's important that everyone sees that. It actually looks like, let me bring up the test. It actually kind of looks like number 6 on the test. Kind of looks like this, right? We have an equation, we've got some x's in here, they're raised to the first power. So we know how to solve linear equations. First thing we want to do for a linear equation is to, well, make sure it's a linear equation. We talked about this last class, I believe. Where was it? I gave you all the steps. Let me just bring them up. There they are. Make sure it's a linear equation. Clear fractions. Okay, clear the fractions. That's what I'm going to do next. So I look at the fractions. I have 2 denominators. I have a 12 and I have a 6. So I find the LCD, least common denominator, which would be 12. I'm not going to go through those steps, but I'm going to assume that you could figure out that 12 is the smallest multiple of both of those. And then do y'all remember what you do with the 12? You remember what you do now?
Would you find the factors?
We got the 12 by basically we got the 12 by listing out all the multiples of 6, right? These are all the multiples of 6. And then all the multiples of 12. And then we tried to find the smallest number that appeared in both of them. So 12 was this LCD, this least common denominator. Then what we do once we have it is multiply both sides of the equation by that number. So we multiply both sides by 12. And when I say 12, I mean 12 over 1, multiplied on both sides. And what happens is the 12s go away, we get X. And then over here, you have an option. You can multiply straight across and divide by 6, or you can realize that the 6 goes into 6 once, and 6 goes into 12 twice. And then multiply across. So multiply here, and then 1 times 1 on the bottom. So you should get 43,000. Now, solving a linear equation, we're supposed to clear the fractions, clear the parentheses, and then we're supposed to isolate x. But see, x is already isolated. So this is our answer, which again, you probably could have told me that a long time ago, but it's more about the process than it is anything else. Are there any questions? Because I'm going to give you a problem now to see if you can figure it out. Well, we'll work through one more together, and then I'm going to give you one to see if you can figure out. All right. So let me. Yeah, I'll just make it up. You know what? We can look. I'll look online for something. Here we go. I'll show you what I'm looking at in a second. Here we go. So if you eat a hard-boiled egg, okay, or do we want hard-boiled? Let me see. Let's do scrambled egg. Okay. So let's say you eat a scrambled egg, right? There's 91 calories in the scrambled egg. All right. So there are 91 calories in one egg. I'm just going to say egg. It's scrambled, okay? Robert consumed 345 calories in eggs. How many eggs did he have? So this problem would be easy if I just said, hey, there's 91 calories in an egg, and then I told you I ate 3 eggs. You could just say, oh, well, that's 3 times 91. That's how many calories. That I think most people could think through pretty reasonably. But this is a little different. I'm not telling you how many eggs I ate. I'm telling you how many calories I consumed. And I want you to tell me how many eggs I ate. So first step, I want to know what it is that I'm looking for, right? So how many eggs, right? That's what I'm looking for. So I want this. I want the number of eggs. And what that tells me is that when I set up my proportion, my number of eggs is going to be on top, okay? My number of eggs is always going to be on top. I'm given a ratio or a proportion. The proportion is that there are 91 calories in one egg. Or you can look at it another way. One egg gives you 91 calories. Now, which one of these am I going to use? The one with calories on top or egg on top? Egg, right? I saw Bonnie say that. Egg, right? Because I'm looking for the number of eggs that I ate. And so the correct ratio to use will be the one that has eggs on it. So let's start figuring this out. Okay, so to solve this, this is the solution to this. I'm going to put X is going to be the number of eggs that I ate divided by the number of calories that I consumed, which was 345 calories. I'm just going to put cal, okay? That must equal 1 egg over 91 calories. And if we look at this purely with just the numbers, without all the units, this is what we have. Now, the technique that I used up here was the technique we learned in class where you would find the LCD and multiply both sides by the LCD, right? That's what I did in class. That's what I've shown you before. But with all proportions, there's a like kind of a shorter, easier way to do it. Does anyone know what it's called? When you have a fraction equal to a fraction, something you can do to solve it. It only works when you have a fraction equal a fraction. Anyone ever heard this?
Multiply.
Good, cross multiply. Okay, now, if you've never seen that, don't worry about it, I'm gonna show it to you. But just please keep in mind, you can only do this when you have a fraction equals a fraction. What we're gonna do is we're gonna multiply the 345 times 1, and we're gonna multiply the 91 times the x. It's multiplying across. So when I do the 91 times x, that leaves me with 91x on the left side. And when I do 345 times 1, that leaves me with 345 on that side, on the right side. And now you just do what you did before with trying to solve for x. So you want to get rid of the 91. So I divide both sides by 91. And I get x on the left side. And then here I'm going to need my calculator. 345 divided by 91. I'm going to get a decimal. 3.79. It keeps going, but I'm just going to stop 2 decimal places. 3.79. So consume 3.79 eggs. You ready for yours? Make yours a little harder, and I'm going to allow y'all, I'll let y'all work. Y'all can talk to each other if you'd like. Let's see how this goes. You ready? So John can paint one wall in 32 minutes. Sarah can paint one wall in, we'll make her faster, 28 minutes. How long will it take them both to paint the 15 walls of a home? Okay, so they're working separately, right? John's off in one room painting, Sarah's in another room painting. I want you to see if you can solve this using proportions and things like that. You might be able to do it some other way where you're just kind of thinking through it, scratch work and everything else. But again, I'm trying to set you up for what's coming later. So see if you can't figure out what it is you want to find, what proportion you're going to use, set up the equation and cross multiply. And why don't I give you, I don't know, 4 or 5 minutes, see how you do. And feel free to talk to one another. I don't want to put you in breakout rooms. I'm just going to let you sit here and see how it goes. 4 or 5 minutes. Okay, everyone, I couldn't get my poll working correctly here. So I sent a poll out. If you put yes, that means you got the answer 900. If you put no, you got the answer 450. And if you didn't get either one of those, then don't answer it at all, okay? So
I
yes-
accidentally clicked the wrong one because it popped up when I was trying to click onto the screen.
Okay, did you get something different or,
Yeah, I meant to click no.
okay, it won't let you afterward again? Won't let you
No.
in? Okay, don't worry about it. We'll give everyone another minute. So if you got 900, click yes. If you got 450, click no. And if you got something else, just don't click anything. Okay, let's stick with that. So we have, as a result, we had 3 students get 900. We had 4 students get 450. Make it 5, sorry. 5 got 450. And there were, I think, 11 of you here. So that means other answer, I think we have 3 that got something else. Okay. So let's see what's correct. So does anyone want to help kind of set this up? Maybe by telling me what we want in the problem?
We want to know the number of the amount of time it would take to paint 15 walls.
Time, right? We want to know the amount of time. Thank you, Tiffany. We want to know the amount of time it takes to do 15 walls. So how long, right? How long? What's the amount of time? So we want the time, right? We want the time, of course, to paint 15 walls, but the key is that we want time. Now we're given a ratio or proportion, and there's 2 different ways you should be able to write this. Can someone tell me what the ratio is? This is, I think, the trickiest part of the problem. Who wants to share with me what ratio they're given?
It's one home, right?
Yeah.
So 1/15.
Okay, so I think, okay, when we're looking at the proportions that we're given or the ratios that we're given, we're trying to think of how many walls can be painted in a certain amount of time by these 2 individuals. So John can do 1 wall in 32 minutes, right? He can do 1 wall, but it takes him 32 minutes. And Sarah can do 1 wall in 28 minutes. So together, how many walls can they do and how much time does it take them to do it? This is the tricky part. Any ideas here? See, this problem is not as easy. It would be a lot easier if it was just John, right? If it was just John, then you would just do, okay, 1 wall in 32 minutes. Or you could do 32 minutes in 1 wall. I'm getting some, what's confusing you? What's causing an issue here? I mean, you should be confused. It's not a straightforward, easy problem.
Would we add John and Sarah's time together to give
Okay.
you like that?
Okay, so let's think about it. So let's say, let's say that 32 minutes has gone by. Okay, let's just say 32 minutes has gone by. How many walls has John done? Okay, in 32 minutes. All right, in 32 minutes, how much has John done? Oops.
Just 1 wall.
John has done 1 wall. right? In 32 minutes, John has done one wall. But how about Sarah? Has she finished a wall?
Yes.
Yes, but she's already started on another one, hasn't she? Because it only takes her 23 minutes. I mean, sorry, 28 minutes to do a wall. So we have to figure out how many walls Sarah's done in 32 minutes. Let's figure out what that is. So this is tricky problem because it's 2 and 1, and I don't expect that people got this, but I want you to see that these proportions can be used to solve harder problems. But is everyone clear that in 32 minutes, John's done one wall, right? Now for for Sarah, if Sarah can do one wall, so let's talk about Sarah. For Sarah, we want the number of walls she does in 32 minutes. Okay, that's what we want to know. We know John can do one wall in 32 minutes, but how much can Sarah do in 32 minutes? Well, that means we want X to be the number of walls that she does in 32 minutes. But what is the proportion for Sarah? She can do one wall in 28 minutes, right? One wall in 28 minutes. So she can do one wall in 28 minutes. And now I can figure out how many walls she does in 32 by doing the cross multiply again. And then divide by 28. So I'm gonna do 32 divided by 28. And I get about 1.43. No, sorry, 1.1. Let's go 1.14. Just round 2 decimal places. Do y'all understand what I did there? Are there any questions? John can do one wall in 32 minutes. Jill, because I keep on saying Jill. Sarah can do a little bit more than John because she's a little faster. In 32 minutes, right, she can do one wall in 28. That means she can do 1.14 walls in 32 minutes. So now, combined together, how many walls can John and Sarah do in 32 minutes? He does one, and she does this many. So together, what do they do? Anyone?
2.14 in 32 minutes.
Sorry, say again.
2.14 in 32 minutes.
Together they can do good 2.14 walls in 32 minutes. Okay, all of this was just stuff I was doing on the side. So John's doing his thing, Sarah's doing her thing. Together, they can do 2.14 walls in 32 minutes. We want to know how much time it takes to do 15 walls, right? That's what we want to know. And what we're given is that together, they can do 2.14 walls in 32 minutes. Or another way of looking at that is 32 minutes. They do 2.14 walls. So we want to know time. So we're going to use this proportion or this ratio, and we will write down the amount of time it takes them over walls, 15 walls. That's what we want to know. How long is it going to take to do 15 walls? Should be equal to the 32 over 2.14. And then we cross multiply. So 2.14x equals, let's see, 15 times 32. equals 480. And then I divide both sides by 2.14. So divide the 480 by 2.14. And you should get approximately 224.29. I'll just round it to 3 minutes. Okay, so I realize this is a tricky problem, all right, because you have to think through the combined ratio. To find their combined ratio, you actually have to do a proportion problem to get it, and then you can use that to solve the bigger problem. Okay, it's 1:34. We've got about 5 minutes. I don't think. Let's see what the next part of this is. Next part that I want you to look at. Yeah, you know what? Let's do this. In the next 6 minutes that we have, see if you can get some of these done. Okay, so we'll take maybe, see if you can get the first one done in like the next 2 or 3 minutes, and then we'll talk about the answer. And do it with the proportion. Don't try and just think through it. So I launched a poll. If you could just tell me if you finished the first one at least, that way I know where everyone is. Okay, that's pretty much everyone. So on the first, I'm gonna do the first one real quick to make sure you get it. So how many times, so in this problem, we want to know how many times does his heart beat in 60 seconds. So we want the number of heartbeats. I'm going to call that X. How many of those do we get in 60 seconds? All right. So we set that equal to a proportion, and the proportion we're given is that his heart beats 11 beats in 10 seconds, or you could write it the other way around, 10 seconds, 11 beats. Which one of those two am I going to use? Am I going to use the first one with the beats on top, or the seconds on top?
The first one.
First one, because we're trying to figure out how many beats there are. That's X. If beats are on top, then that's what goes on the other one. And then you cross multiply. So you should get 10X equals, what is that, 660? And then you divide both sides by 10, and you should get 66 beats. All right, so we are just about out of time. Here's what I'm gonna do. I appreciate everyone coming back after the test to do this. I'm gonna reward you for that. So these two problems, if you do those on your own, on a separate sheet of paper, and you submit those into the same Dropbox that the test was in, just when you submit it and just put on it like, title the file something like bonus question. So if you can get both of those right, show me the work, then I will add 5 points to your exam grade. So they're each worth 2.5 points, all right? But I need those within the next, let's say, hour, okay? So if you can get that to me in the next hour, then you can get up to 5-point bonus on the test. Okay? All right, everyone, have a great day. We'll be back Wednesday, and I will I will do my best to get your exams graded. So keep an eye on your exam grades. If your grade shows up in Canvas, you should be able to click on it, and it will have a copy of your test with my markings on it. Okay, so you'll be able to look at your test, your graded test, see what you got right or wrong. Hopefully I can have that done by tomorrow. Maybe tonight, we'll see. Have a good day.
Bye, thank you.
Oh, sir, do we still have to do the
Sir, I had a
homework?
question.